start? Alright, so this lecture, for lecture 6, we're going to talk about something called the decision tables and decision trees. Previously we talked, last 2 weeks, we talked about something called that flow diagram. We talked about the flow chart and data dictionary. And all of these topics actually they use to describe the information system in an abstract way. Today, we're going to use the decision table. The decision table, actually, we can use it to represent the business logic. So we're going to go deeply inside the information system to represent the business logic. So how can we represent the business logic using the decision table? Decision table comes with three parts. It comes with conditions, outcomes, and rules. So today we're going to talk mainly about the decision table and decision trees, and how can we use these conditions and outcomes to represent the decision table. So basically, in terms of the system development life cycle, we are still with the system design. If you remember, data flow diagram was the stage of system analysis. Flow chart was system design as well. So decision table, actually we can say a table contains a set of conditions. Each condition corresponds with an outcome or an action. Okay? So for example, this is the basic structure. This is the basic structure of a decision table that we're going to create by ourselves. For example, from the left side, you can see we have conditions, we have outcome. So now this example shows the verify order process. So as we said, the left side comes with two parts, conditions and outcomes. How many conditions do we have? We have two conditions. Credit status is okay and product is in stock. Two conditions. While the outcome that reflect to those conditions are actually accept order and reject order. All right. In the right side, actually, we have the rules. The rules. What do you mean by rules? Rules mean the probabilities that reflect to these conditions. Okay. So you may have a question. For example, how can we know? We have, for example, 4 rules here, 4 columns. Each column is a rule by itself. All right. How can we know the number of rules for the decision table? You have an idea? No? All right. How many conditions do we have? 2 conditions, right? Keep this point in your mind. You have a formula, 2 power n. All right? So when we say 2 power n, n is the number of conditions. So we will say, when we have, for example, 2 conditions, 2 power 2, how many? 4, right? 2 power 3, 8 rules. 2 power 4, 16 rules. All right, and so on. So the rule is here. So it's something like 2 power n. And the n here represents number of conditions. All right, so for example here we have two conditions, so that means we have 4 rules, 4 columns that reflects the probability of the 2 conditions. All right, for example, credit status is all right, is okay. All right, so the first condition will be yes or no. 2 rules, yes, no, true or false, you can say as well. So for example, the credit status is okay. So we have yes, this is the first rule. The second condition is product is in stock. Yes. So the outcome will be accept order. This is of course the same when you order something. So for example, you're gonna verify your credit card, for example. This is the first step. Verify the order, verify the credit card. All right? Second, actually, we need to check if the order or the item that you're ordering is in stock or not. So if both conditions verify, that means the outcome of this process is yes. So we will accept the order. So we would say X means the order being accepted. Look to the second rule here. When the credit status is alright, is okay, while the product is not in stock, means no. The outcome, reject order. Third rule, when the credit status is not alright, something wrong with the credit status, for example, it's expired or you don't have sufficient fund, for example, while the product is still in stock, but still reject order. For the fourth rule is that when both conditions actually no, the credit status is not alright, something wrong with that, product is not in stock, out of stock, so the outcome here, reject order. Alright, so basically this is the structure of decision table. You have conditions, you have outcomes, and you have rules. Number of conditions will determine the number of rules. How many conditions do you have? 2 power number of conditions, you will have number of rules. Alright? Again, number of rules it represents the probabilities of all conditions. So for example, 2 conditions, that means you have 4 probabilities. Basically, when you start drawing or when you start creating your decision table, just say, for example, if you have 2 conditions, yes, yes, no, no, yes, no, yes, no. You fill all the probabilities of 2 conditions. Alright? Now, this is the first step for creating a decision table. Conditions, outcomes, and rules. Do we have a second step? Yes, we do. Second step is actually to simplify the decision table. Now the example that we're showing to you actually quite simple. It comes with just 2 conditions. But imagine you have an information system, and of course the information system doesn't come with just 2 conditions. It comes with many conditions, right? So imagine, for example, let's take 4 conditions. 2 power 4, you will have 16 rules, alright? So even more, when we have 16 and more, we need to simplify that decision table to make it quite simple, to make it understood by everyone, alright? So, how can we simplify the decision table? A decision table can be simplified. In the table, rule 3 and 4 show the same outcomes, regardless the status of product in stock. So, in order to simplify any tables, any decision table, we need to look, for example, at the outcome. When they have the same outcomes, for example, we cannot simplify, we cannot combine those 2 rules, 1 and 2, because they are different, they have different outcomes. So totally they are different rules. So in order to combine those 2 rules, so first we need to check they have the same output, they have the same outcome. In addition to that, actually, they are sharing the same first condition, no, no. So, regardless condition 2, the 2 rules have the same output. They have the same outcome. Alright? So, we can combine those 2 rules to be something like that. Rule 1 is still the same, Rule 2 is still the same, but Rule 3 actually is still the first condition, no, but we need to replace the rule of second condition with dash and remove column 4. Alright? So at the end, this is our first decision table that reflects to verify order process, and this is the simplified one, the simplified step. Step 2 of a decision table. Instead of 4 rules, now we have 3 rules. Alright? The first rule, actually, when both conditions yes, the outcome will accept order. The second condition, when the first one is yes, and the second condition is no, the outcome reject order. The third condition, when the first condition no, regardless the second condition, the outcome is reject order. So this is the basic idea. Create the decision table, and then we need to find those rules that they share the same outputs. They are sharing the same outcome. We need to combine them to represent one rule. All right? So this is an example about creating a decision table to verify order process and then simplify it. So basically there's 3 steps to create a decision table. The first one, we need to identify all conditions and the outcomes. List all the combination of conditions with the outcomes. Simplify the decision table. All right? Keep in mind, when you want to create a decision table, you need to identify the conditions. First, you need to identify the outcomes. And from the number of conditions, you will have the number of rules, the probabilities that reflect the conditions. Once you create your first table, first decision table, this is the first step. The second step, you need to simplify the decision table by combining those rules that sharing the same outcome. All right? Okay, so example 2 actually is quite similar. It's quite similar to previous one with just one extra condition. Look here. Previously we had 2 conditions, right? Credit status is okay, and product in stock. 2 conditions mean how many rules do we have here? 4. 2 power 2, 4. Now the same example but with extra 1 condition, right? So 3 conditions. How many rules, how many columns we will have? 8. 2 power 3. So we will have 8 rules or 8 columns. All right, so as we said, we have 3 conditions. So we have 3 conditions. That means we're gonna have 8 rules or 8 columns that reflect the probabilities of these 3 conditions. We still have 2 outcomes: accept order, reject order. All right, so let's talk about the first rule here. The first rule is when the credit status is okay, all right, and the product in stock, yes. Waiver from credit manager, yes. So the accept order, the outcome will be accept order. The second rule, when the first condition okay, second condition yes, third condition no, we still accept order. All right. Third one, yes, no, yes, reject order. Fourth one, yes, no, no, reject order, and so on. Now you may ask, based on this question, how can we identify the accept order and reject order? This is just example. Of course, there's an explanation about the case. We can have example later on. All right. So basically, now I'm just showing to you how can we have the decision table. What do you mean by conditions and the outcomes? Later on, when we have a case study that explain all of these conditions and the outcome. From the case study, you will identify the conditions. You will identify the outcomes as well. And from the number of conditions, you will identify number of rules or number of columns. All right, so okay, so as we said, this is the first step of creating the decision table. What we need to do next? As a second step, what do you think, guys? Simplify the decision table. All right, simplify the decision table means we need to combine those rules that are sharing the same outcome. All right, so what do you think now? Which rules we can combine together? 4 and 5? Can we combine 4 and 5? Why? 4 and 5? Looks good.
No.
Why no?
Different outcome.
Absolutely correct. Different outcomes. So once you see two rules with different outcomes, just ignore them. Don't put them in your consideration. Look for something, rules that came with the same outputs. Alright, so 1 and 2, are they sharing the same outcome? Yes? Alright. So the same outcome, which is accept order. Look to the condition. The first one is yes, the second rule is yes. For the two rules, the two columns, the first condition is yes, right? Alright, look to the second row. Product in stock, both of them yes. The third one, yes and no. So, regardless condition 3, the two rules sharing the same outcome. So, can we combine them? Alright, so this is our first pair of rules. What else do we have? 3 and 4? Can we? Alright, so the same outcome, both reject order. The first condition for both of them, yes. The second condition, yes, no. Third one, no and yes. So second condition, both no. Third condition, yes and no. What else do we have?
7 and 8.
Absolutely correct, 7 and 8. So both of them actually, they have the same outcome by reject order. The first condition for them, no, no. Second condition, no, no. Third condition, actually, they are yes and no. So the rule here, regardless condition 3, rule 7 and 8 sharing the same outcome. Alright? Alright, so you were right. So 1 and 2, our first pair, we can combine them. 3 and 4, the same thing, 7 and 8. So we have 3 combinations here. And while 5 and 6, of course, they are sharing the different outcomes. So of course, there is no way to combine them, to simplify them. Alright, so because let's talk about the first combination here. 1 and 2, we said they are sharing the same outcome, the same condition for the same rule for the first two conditions, while regardless the third one. So the third one actually we need to replace it with dash. Alright? We need to replace it with dash. That means we're going to consider only the first two conditions because the third condition doesn't affect the outcome of the rules. Alright? So we're going to ignore it by replacing the rule of that condition with what? With dash. So we would say credit status is okay. Product in stock, yes. Regardless condition 3, we still have the same outcome. The same output for these two rules. Alright? Look for 3 and 4. 3 and 4, yes, yes, no, no, while the third one is yes, no. So regardless condition 3, we still have the same output, which is reject order. And we need to replace the third one with dash. The same thing for 7 and 8, no, no. Only with the third condition, regardless the third condition, we still have the same outcome here. Alright, so now you may ask yourself, alright, Osama, you said we need to replace the condition that, regardless that condition, we need to replace it with dash, right? So why we have replaced the first condition for 3 and 4, 7 and 8 with dash? Why? Alright. Where's the pen? Okay. Okay, so what is the output of this one after the combination? So the output will be y n dash, right? and the output is X. Am I right? So they are the same out. The first condition, yes. The second condition, no. Regardless, the third condition, we replace it with dash. And we still have the same outcome. Okay, this is for the first row. All right? All right, so let's do this one as well. So the first condition is yes. The second condition, sorry, no. The second condition, no as well. The third one, yes, no. We need to replace that one with dash. And we still have X as well as the outcome. Right? All right, so again, now we have two rules, right? Simplified from our first decision. But still have the same outcome, right? And look, sharing the same conditions. Yes, no, this is different, and no, no. So, regardless the first condition, we still have what? The same outcome. All right. To simplify these two rules, we're gonna have dash, no, dash, and the outcome is X. All right. So this is the simplified one from those two rules that already simplified from the decision table. All right. So at the end, we're gonna have something like that. So the first one actually, yes, yes, dash X, no, yes, yes, X, no, yes, no, X, and the fourth one, no, that represents the simplified rules from the decision table. All right, guys? Is it clear? Do I need to explain again? All good? Guys, do you have a question? All right. So, as we say, the decision table, you need to identify the conditions. You need to identify the outcomes of these conditions. And then from the number of conditions, you will know how many rules you will have. And these rules represent the probabilities of the conditions. This is the first step. The second step, we need to simplify the first decision table to another decision table. So we need, at the end of the simplification, we need to reduce the number of rules. All right? How can we simplify? By combine those rules that are sharing the same outcomes. All right. Any question about the decision table, guys? Is it clear? All right. So we're going to have examples, actually. Class exercise. So now we're going to talk about decision tree. A decision tree is a tree structured graph with each branch represent a condition that leads to an outcome. So for example, you want to go to a Latrobe to attend the IS lecture at 9 a.m. and you still have, for example, 20 minutes. All right? You still have just 20 minutes. So how can we represent that scenario in a decision tree? First of all, your first condition, you need to check, it's raining or not. It's raining? If it was yes, of course you will not be able to get to your lecture within 20 minutes, right? So of course the outcome will be a drive. It's better to drive to save your time. If it wasn't raining, so of course that means no. You will have another condition. You need to check your time. You still have 20 minutes to get to the lecture. All right, so if it's less than 20 minutes, of course, again, you need to save your time. You're going to take tram. Otherwise, all right, you still have 20 minutes, or for example, 30 minutes. All right, so you said, okay, I will be able to get my lecture on time. So of course, just I will walk. So based on this scenario, you have conditions and you have outcomes. How many conditions do we have here? What do you think? How many conditions? The first one, is it condition? It's raining. Yes or no? Is it condition? This is our first condition. So if it's raining, I will go dry. So this is the outcome of the condition. If it's snow, I need to check less than 20 minutes. For example, I still have 15 minutes, not 20. So from the 15, I will not be able to get my lecture on time. Alright, so what I need to do, I will take from. So can we say the condition less than 20 minutes left is a condition? This is our second condition here. So we have two conditions. Alright? It's raining or not, less than 20 minutes left. What about the outcomes? The outcome of these two conditions actually drive takes from and work. Because these are the outcome of the conditions. Alright? So basically, since we have two conditions, if we want to represent this decision tree as a decision table, how many rules we will have? How many conditions do we have? How many rules? 4, absolutely correct. 2 for 2. 2 power 2, you're going to have 4 rules. All right, so we have here another example about decision tree. Preferred customers who order more than 1,000 are entitled to a discount, 5% discount, and an additional 5% discount if they use our charge card. Preferred customers who don't order more than 1,000 receive 25 bonus coupon. All other customers receive a 5% bonus coupon. All right. So from this short, let's say case study or a sample, we need to find our conditions and the outcomes. All right. Based on that, preferred customer who order more than 1,000. Can we say this is a condition? Preferred customer? Do we have a preferred customer here? So can we say this is as a condition, right? Okay, so that customer, if he order more than 1,000, well, he will get 5% discount. So 5% discount is my outcome. Alright, so my outcomes, first one is 5% discount. Alright, and an additional 5% discount if they use our charge card. Can we say the use company or use charge card is a condition by itself? Yes. What is the outcome of that condition? Additional 5% discount. So now we have two conditions and two outcomes. All right, continue. Preferred customer who don't order more than 1,000 receive actually 25 coupon. So now previously we have those preferred customers who order more than 1,000. Now the case about preferred customer who don't order more than 1,000. What he will receive? 25% discount. All other customers receive 5 bonus coupon. Alright, so my conditions now, preferred customer, order more than 1,000, used company's charge card. Alright, the outcomes, 5% discount, additional 5% discount, 25 bonus coupon, 5 bonus coupon. So I have 3 conditions plus 4 outcomes. So basically now I have three conditions. How many rows I will have? How many columns? 8 exactly. Now to represent this scenario in a decision tree, first of all, actually, we're gonna say the preferred customer. All right. So yes or no? Is he a preferred customer or no? Look here, preferred customer. as we said, preferred customers who order more than 1,000 are entitled to a 5% discount, all right? And an additional 5% discount if they use our charge card. Now, if all other customers means those who didn't receive, who they are not preferred customers, or they didn't order anything actually, so they will receive 5 bonus coupon. So preferred customers, if we said no, that means it's not preferred customer, but he will get 5 bonus coupon. All right, if we said yes, all right, if we said yes, go back to the first sentence. Preferred customer, yes, he's a preferred customer. All right, is that the preferred customer order more than 1,000? Let's say no. All right, so preferred customer who don't order more than 1,000 receive what? 25 bonus coupon. So he's a preferred customer, okay? But he's not ordering more than 1,000, so he will receive just 25 bonus coupon. What about if he preferred customer? Yes, he ordered more than 1,000. Yes, okay. Order entitled to 25 discount. And if he use our charge card, he will get additional 5% discount. Did he use for example, our charge card? No, he will get just 5% discount. The first one, entitled to 5% discounts. And an additional 5% discount if they use our charge card. Did they use our charge card? Yes, give him another 5% discount. So, if he preferred customer, if he order more than 1,000, if he use our charge card, actually he will get 10% discounts. 5 plus 5. If he preferred customer, if he order more than 1,000, okay, but he didn't use our charge card, he will get just 5% discounts. If he preferred customer, he didn't order more than 1,000. For example, he ordered 900, okay, so he will get just 25 bonus coupon, not a discount. Okay, all other customers, they are new customers, for example, they will get just 5 bonus coupon. All right, so this is an example about how to represent the decision tree using the conditions and the outcomes. Okay, guys, any questions so far? Any question about the decision table or decision tree? All good? All right, now your turn. Please have a look at this class exercise, read the case study, and try to have your decision table and decision tree as well. All right, so just for the next 5 minutes. Yes? Yes, look here. Yes, no. Yes, 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 yes. But even though it's better to, for example, you can compare those two rules we have first. Actually, if you combine, for example, 1 and 5, you still have number 2 and 1. Okay, so it's better to combine 1 and 2 by itself, 3 and 4 and 7. Look, let's two by 2. So those two they can combine together. Those next two can combine together. The next two actually cannot be combined because they have 4 different. If we can do that, we can do that on just 3 work for a week. Okay. It's not done, we just
It's like the smallest one you can get.
Smallest one.
Yeah. It was the only place where this file is on this computer that couldn't show any of it. But I'm missing look at it. I'm missing all the layers. This is the only copy of the file. So if they did, how is it going to all file? It's there. So why is it there? This is an old version of the file. This one. When was this photo taken? I haven't touched it. The only thing I have to do about it is
Okay, guys, done? All right, so you have a case study and your task to have your decision table and decision tree as well. So first of all, let's talk about the decision table. In order to draw the decision table, what do we need to have first? Yes?
The outcomes of the decision.
The outcomes and conditions. All right, all right. So based on this case study, how many conditions do we have? Or what are the conditions? Guys, how many conditions? What are these conditions that we're going to use them for our decision table? Do you have an idea? Sorry? Absolutely correct. This is our first condition. What else? All right, so let's read the case together. Roxol, so look here. Roxol will provide free shipping for any customer. Either complete. Okay, so either completes an online survey. Okay. Complete an online survey form or signs up for the online newspaper. So how many conditions do we have here? We have two. So we have if the customer, he did the survey or signs up. All right, so we have two conditions. Additionally, if a customer completes the survey and signs for the newspaper, Roxalt will provide 10% for order 1,000. So if he order more, 100. So if he orders over 100, what he will get? So basically now, how many conditions do we have? First, if he completes the survey online or signs up, right? Two conditions. What else? To the last sentence. We'll provide $10 for what? So can we say this is a condition? Yes. So how many conditions do we have now? 3 conditions. All right? 3 conditions. All right. So we have identified, we have found that we now have 3 conditions. Now let's talk about the outcomes. All right. So let's read again. Russell will provide what? Free shipping for any customer. He either completes survey online or signs up. So what is the outcome for those 2 conditions? Free shipping. So if a customer, he did the online survey or signs up, what he will get? So if he completes an online survey or sign up, he will get what? Provide free shipping for any customer. So this is my first outcome. What else? Additionally, if customer completes the survey and signs for the newspaper, Roxel will provide 10 for. Did we say this is a condition? Yes. Right. So what is the outcome of this condition? Right? So basically now, how many rules do we have? How many conditions do we have? We have 3. How many outcomes? 2. How many rules we will have? 8 rules. Because 2 power 3, so it means 8 rules or 8 columns. These rules represent the probability of all these conditions. All right, so now let's have a look about our on the conditions. Complete the survey, signs up, order over 100. The outcomes: free shipping and 10%, $10. The outcomes. Look here. Other rules we said we have 3 conditions. So complete survey form and sign up for the newspaper, order over 100. So these are the conditions. What are the rules? Free shipping and $10 as credit. These are the outcomes from those 3 conditions. So again, since we have 3 conditions, so we can apply all right, so 3 conditions. We were talking that we have 3 conditions, we have 2 outcomes. So based on these 3 conditions, of course, based on the formula, that which is 2 power n, all right, so power and n reflects what the conditions here. How many conditions do we have? Reflect the number of rules, the number of columns. 3 conditions means 8 rules or 8 columns that reflect the probabilities of these 3 conditions. All right, so if a customer, he complete the survey, yes. If the customer signed up for the newspaper, yes. If he order above 100, yes. Of course, he will get free shipping and he will get $10 as credit. This is the first rule. The second rule, if he complete the survey, if he signed up for the newspaper, but he didn't order above 100, he did order, for example, for $90 or $80, of course, he will get still free shipping, but without any extra 10 credits. The third rule, he did complete the survey, but he didn't sign up for the newspaper, but he ordered over 100, he is still getting a free shipping, but without any 10 credits. And the fourth one, yes, no, no. So he will get free shipping for the 5th and 6th as well. Look for the last 2 rules. If he didn't complete the survey, if he didn't sign for the newspaper, if he didn't order something above 100, he will get nothing. No free shipping, no 10 credits. If he did order above 100. So didn't complete the survey, didn't sign for the newspaper, but he did